Hey, HB Tunes, this is Rob Jensen. I'm coming with you today. I'm going to be going through the SAT April 2018 Section 3 Math section, no calculator, kind of walking you through some of the solutions that we have for this section of things. Uh, Things to kind of keep in mind, we're definitely going to be working on trying to point out some things that may be um, evident in your ability to sort of see the answers and stuff, or understand the types of questions that are being given to you, and helping you in your ability to sort of type those things. So let's go ahead and proceed here. So what we see here on this first question that we have, we look like we know we're dealing with the systems of equations of things, and within it, certainly there's some things that we can possibly do. A couple different ways that we can try to solve for this. Usually we want to try to maybe look and see if we can do elimination on such a problem like this, or if not elimination, maybe transformation, which in this particular instance, that might be the best case. Or you could try doing substitution, so that could just maybe work as well. But let's try to do with transformation first. We see we have plus y here and negative 2y here. So with that, we could just sort of take this and multiply everything by 2, and then that would allow us to eliminate the y. So now we have 2x plus 2y equals 42. And then on the bottom we have x minus 2y, which then equals negative 3. So here, in adding these values, and looking at this question, we're looking for the value of x. So that reason we want to eliminate our y's here. That's why we're doing that. So now we're left with 3x then equals 42 minus 3 is going to give me 39. And then from there, we can divide by 3 and stuff. And we get x equals 13. So that gives us answer choice C on this one. Let's look at the next problem that we have. Let me kind of reduce the size of this a little bit. So here we see we have which the following is the graph of the equation of y equals 3x minus 2. And so we've taken this slope-intercept form and graphing it on a coordinate plane. Well, one of the first things we sort of want to be able to look at is we can see that we're talking about here, it talks about, first thing is the y-intercept. Remember, we're talking about y equals mx plus b. That's our slope-intercept form. So we want to focus on the y-intercept first. And so the y-intercept here, which is b equals negative 2 here, so we can say, okay, b equals negative 2. Well, that's at 0, so that's not it. That's at negative 2, so that checks out. That's at 1, 2, 3, so that doesn't check out. And then scrolling to the bottom, we could see that is at a positive 2, so that does not check out. So just going through that procedure there, we can see that the answer choice here is going to be B. We don't even have to look at the slope. So if we did have to look at the slope, then remember the slope, which would be equivalent to rise over run, which in this case would be 3 over 1 and stuff. And we can see that on this one. It goes up 1. Sorry, that goes up. So it goes up here, goes up 3, and then over 1, and that agrees. It checks out. So making that correct. Okay, let's look at the next problem that we have here. Of sorts. It says which of the following expression is equivalent to x squared plus 10x plus 21. Okay, so look at this. We're trying to find an equation that so happens to mimic what we have here of things. And so we want to sort of be able to, one of the things we can kind of look at this one and understand that what's not a correct answer choice is because here we have x and times x. So we know that when we factor these two, that's going to give us x squared, right? And so we have an x squared here. And then same thing here, we're going to have an x squared, but then you're adding another 12x of things. So let's see here. So factoring this piece out, so we know that we're going to get x squared, and then folding it again, so going across through here is going to give us plus 9x, and then right there is going to give us plus x, and then 1 times 9 is going to give me give me 9. And then we have this positive 12 here that we're adding on the end of things. So combining these terms, we see that we have x squared plus 10x plus 21, which then happens to match what we have here. There's really not a good, easy way to sort of go through this or to even eliminate. I mean, you probably could. I mean, you could look here and you can see like, okay, that's already given me 21 and I have 21 up here of things. And so you can, the same thing here. Well, that's because you're adding the 5, so you know that's going to be greater than, so that's not going to necessarily work there. And then just as well here, multiply that, you know, that's only going to give me 9. And so you can kind of go through it, maybe eliminate some things that are potentially in that way. Okay, let's look at the next problem here, number 4. So we see that we have a system of inequalities here. And since these do not agree, we see we have y is greater than or equal to, and then y is greater than and stuff. So because of that, you can't really bridge these two like you would want to. Now, if they were greater than and less than, both of them are the same way, then you could do that, but we couldn't do that here. So what we can do is we can just sort of plug in values and try to do what we call is trial and error here. You know, plug in values and see if they may so happen to work. So if we take the first one, and it says y should be greater than or less than the negative 2x plus 1. So if that's the case, then this should read for the first one, it says y is greater than or less than negative 2 times 2 plus 11. So then you got y is less than or equal to negative 4 plus 11, which we see that is not correct of things. And so that does not agree, and so automatically A is not it. So let's try the next one, doing the same procedure of things. So if we have, this is A, and so let's try B real quick. So we'll see that y is less than, we don't necessarily have to go through the second equation, because if it's not correct for the first equation, it won't work for the second equation. So 1 is greater than or equal to negative 2 times 4 plus 11. So again, we see that's going to be 1 is less than or equal to negative 8 plus 11, which again, that's not true either. That stuff, so we know that B is not the answer choice. So let's try C real quick then. So we'll try C, and if it's not C, then we automatically know that the answer choice has to be D. That's kind of the beauty of trial and error. So we have 5 is less than negative 2 negative 2 times 4 plus 11. And so here we get 5 is less than or equal to negative 8 plus 11. And that is true. And so we can see the answer choice here is C on this one. Okay, so let's look at the next one that we have over here of things. We can see it says in the XY plane, it says line L passes through the point 0, 1, and 1, 4, which the following is the equation of line L. So really what we're doing is they've given us 2 coordinate points, and within that, 2 ordered pairs, and within that we can identify what happens to be the line. Well, one thing we know, if x equals 0 here, then we know that our y-intercept is 1. So we say x equals 0, then y is going to equal 1. Well, and then so you can see here, we can now eliminate B as an answer choice for that reason and D for that reason. So we know we're between A and C as answer choices for that reason. So all we're going to do is figure out the slope. So we have our x1, y1, x2, y2. So remember slope, y2 minus y1, and then x2 over x1. And we can see that, okay, 4 minus 1 over 1 minus 0. And that's going to give us 3 over 1, which is going to give us 3. And so therefore, you can see that does not work. Therefore, C is the answer choice on that one. All right, number 6. Now, keep in mind that what we have here is we see, because we have a variable underneath the radical, this is going to be a radical equation here. Keep this in mind. This is a radical equation. And for that reason, within some of these, remember, it says which value of x satisfies the equation of O. So if we plug in a value here, it should give us 0. of things. And sometimes the best thing to do on these is to take the values that have been given to you and then being able to sort of solve them in that way and stuff. So, in doing that. This one's a little bit more complicated and stuff, so we'll just sit here, we'll take these values and plug them in. So we'll try A first, okay? So we'll try A here, and see what we get is we get the square root of 8 plus 28 minus 2 square root of 8 plus 1 equals 0. All right, so let's simplify these now. So now we have the square root of 36 minus 2 times 9 equals 0. And so from that, we can now simplify these. So the square root of 36 is going to give me 6 minus 2. Square root of 9 is going to give me 3 equals 0. And we can see that when we finish this out, that we get 6 minus 6 equals 0, which this is indeed true, and that makes the answer choice A correct. So quite often, when you're a little uncertain about radical equations and you're given the values here, use trial and error, and that will definitely help you. Okay, number 7 here that we have. Looking at number 7 that we have here, we see that we're dealing obvious with angles and lines, coming from the additional topic math section of things. And within this, it says within a triangle ABC above, AC is extended to point D. What is the value of y minus x? We want to keep in mind that's a little curveball there and stuff that we have. So within that, we want to be able to sort of solve for these. Well, we see that inside the triangle, remember, is 180 degrees. And what we have here is this is a supplementary angle attached to a triangle. Now remember, y is going to be equivalent to these opposite two. That's just an easy way. Remember that rule that we had about that is that when you have an angle, a line attached to a triangle, that this angle here is the sum of the opposite two angles. So that means that's going to be 140 degrees because you have 135 and 105. And so if that's 140, then we know that x has to be 40 degrees because collectively between these two, okay, that has to be 180 degrees. So it's saying what is y minus x? Y is 140, x is 40, so we get a value of 100 degrees, which is C. Okay. Number 8 here. So this one's a little bit unusual, and you don't really see this concept that often within the SAT. It says in the xy plane to point 26, so this is ordered pair. Remember, anytime you see ordered pairs, these are essentially xy values. So you're looking as to where you can put those things in. And it says lies on the graph of y equals kx, where k is a constant. Okay, so that means whatever value we put into these two, take these and put them in over here, we get the value k, which the following points must also lie on the graph. So it must be equivalent using the same k value. So if a k is a constant, then we know that if y equals k over x, then we know that k is going to be, because we got to multiply by x here to get rid of this. So so that means k is going to be equal to xy. Okay, so we're looking for something that is the same. So if k equals xy, that means 2 times 6, because x equals 2, y equals 6. So 2 times 6 is going to give me 12. Well, which other one of these gives me 12? So 1 times 3 is going to give me 3. 1 times 4 is going to give me 4. 3 times 3 is going to be 9. 3 times 4 is going to be 12. So the answer choice on this one is D. Alrighty. So let's go look at the next problem, number 9 here. So number 9, we don't really have to read all this. You know, this is kind of really irrelevant. The only thing we're looking for is we see this in terms of, remember, so what this is a rewriting an algebraic expression, okay? And so we're not really concerned about all this mean. And all this really going to do is just sort of like confuse you. The only thing we understand and need to know is it says Q equals, and we're going to H equals. So we're trying to isolate the H here. That's all that matters. So let's write this again. So we can see we got 2dk so that we can solve for this. The square root. So what we need to do first to isolate H here is we need to square this. If I square this side, then I have to square this side. So now I have Q squared equals 2dk over H. And for that reason, since we have Q squared, we know A is not it, we know B is not it. The other thing is there's a couple different ways we can do this. We can say Q squared is over 1 equals 2dk over H of things. And there's a couple of things you could do. You could either cross multiply and divide, or if you're a little bit more savvy, you know that to put the H on top, what we could do is flip this and then flip this and stuff. So now this reads as 1 over Q squared equals H over 2dk. And we now know we need to multiply by 2dk. Same thing over here by 2dk. And what you end up getting is 2dk over Q squared equals H. And leaving you with the answer choice C. Okay. All right, number 10. So what we're looking at in number 10 here is we're talking about a linear equation. Because remember, there's only x's here. There's no x squareds. And it's talking about if the equation above C is a constant, if the equation has infinitely many solutions, okay, infinitely many solutions, what is the value of C? Now, keep in mind here, if it's infinitely many solutions, then the values, the constant values that you end up in the end have to agree with one another. Things. And so, and also the other thing that we're always trying to do, whether it's infinitely or no solutions, the main thing is we're always trying to eliminate the x's. Okay, we're always trying to eliminate the x's. So let's go ahead and distribute this thing, because we've got to distribute this into this and this into this, right? So let's rewrite our equation now. So now we have 8x minus 2xc minus 2x, which then equals x. And so we want to then combine our like terms that we have here, things and stuff. So we can see we have negative 2x, we have 8x, and we have x. So let's simplify this left side first. So now we have, say, 6x minus 2xc equals x. All right. And then we can take this piece and let's shift it over to here. Okay, so now we have minus 6x. Okay, because we've got to get rid of this over here. So now we have negative 2xc equals negative 5x. But what we can now do is to isolate the c value, because it says what is the value of the c. Okay, is we can now divide by negative 2x here. Same thing, negative 2x. The x's will now eliminate each other. The negatives will now eliminate each other. So you're left with c equals 5 halves. And the answer choice would then be B. Good deal. Alrighty, so let's look at the number 11 of things. Now, what we're looking at on number 11 is it says, well, we see is this linear equation, right? And then it's kind of asking us, like, what is going on in this? Now, remember, this is the linear equation variety. This is a modeling question. Okay, remember, modeling questions are asking about a piece of what is going on up here. And usually with the modeling questions, we want to be able to sort of eliminate things by the units for which we're being asked of. So in this, it says in 1962, the population of a bird species was 2,000, which we see that's being indicated here. So what we know is that this, if we kind of write out our formula, we can see that the population 2000 of things. That's kind of where it's what it started off at. Population K years after 1962 was 48 of things. So what's really happened is we have B minus MX equals Y. That's what's happening here, and what we can see. And I encourage students to sort of write out the equation because we started off with 2000. Okay, so that's what we know. Remember, we're talking about the intercept. Intercept means that's kind of what we always so happen to begin with at the start, or the beginning, or the initial, or anything that they say that kind of so happens to represent that language. K satisfaction. Which of the following is the best interpretation of the number 61 in this context? Now, 61 we see is referencing the slope, and we see it's going down of things. Okay, so the M equals negative 61. And the M is also referencing, remember the M, the slope, is always talking about some sort of increase or decrease of some variety of things. And it's also going to be the Y unit over the X unit of things. So first off, if I know we're talking about the number 61, I'm going to go through here and look and see which one's talking about an increase or decrease. Nope, nothing in A. Value came, nope, nothing in B. Any increase, decrease? Nope, none of that. Here it is, D, the average decrease. So quite honestly, I don't even have to really look at the rest of this. I just know because we're talking about the slope in negative 61, it's talking about a decrease of some variety. I know the answer is D. Okay, let's look at number 12. So here we're graphing a polynomial, a quadratic polynomial of some variety. So we're looking for our x-intercepts, for which we have here. Things, and so we kind of want to go through and in the process of eliminating them, and so we know with our roots that this right here is negative 3, so that has to be a positive 3 that we then have as a binomial term or some sort, or a term that we factor on, a factored term. This is a factored term. So this does not work because this is x minus 3, which will then suggest that our intercept is at positive 3, so that's not true. So A and B are gone for that reason. We then see we have a negative 1, okay, so which means that we have to have a minus or positive 1 term, which we have here and here, so that kind of checks off. And then here we have a positive 2 term, which means I then need a negative 2 term. So what we're kind of left with, to some degree, is trying to understand whether we have double roots or not and stuff. And when you see a term that's sort of doing this resting on the axis, as you see, this one's going straight through. So that's only one term going through here, which you can see this one is x plus 3 squared. So that makes that wrong. And you can see this, that is what we call a double root, and that is a double root and thing. So that makes these two correct. So D is out, C is the answer choice there. Okay, number 13 here is another systems equations. And so in looking at it, we see that what we have here is one that represents the equation of a circle here, things, and then we see another one that is so happen to be representing just a linear equation. So this is really unusual. You haven't really seen this much on the SAT. Traditionally, it's going to be a quadratic paired with a linear. But what we can do here is we can take this right here, take this equation, because this is y equals, and then be able to insert it right there. And then just solve. So that's just the best way for us to do this. It's going to involve some algebraic work of sorts, but it is very manageable. But that's just a recognition that we kind of need to have, is that we got an equation of a circle here, and we have a linear equation. And there's really no other way to solve for this except for just going through the legwork and putting that in. So let's write this out. So that's x plus 2 squared. So that's going to be x plus 2 times x plus 2 plus, which we now see is going to be negative 2x plus 4. And then we see minus 3. Okay. And then we know that that equation will be squared. So we have to simplify the piece inside here before we can double that up with things. Okay. So here we see now we can do this side here first. So let's bring it down here, make it a little more space. So we have x squared plus, which is going to be 4x plus 4, and then we now have plus, which is now going to be negative 2x plus 1 squared. And so now we need to work on squaring this side. So that's going to be, let's write this out again. So x squared plus 4x plus 4. Negative, so let's be negative 2x plus 1 times negative 2x plus 1. So that's going to give me positive 4x squared. So it's going to be positive 4x squared. That's going to be foiling that piece to that piece, and this piece to this piece. That's going to be negative 2x minus 2x plus 1. So let's combine all of our like terms. So 4x squared, x squared is going to be 5x squared. Okay. 4x. So we got 4x, and then we have minus. That's going to be collectively 4x. So that's going to be, those are going to cancel each other out. It looks like the things. And then 4 plus 1 is going to be 5. So 5x squared plus 5 equals 0 of things. I'm sorry, equals 40. My apologies. I forgot to bring the 40 down. I can't forget the 40. So that's, let me correct that. Sorry. Delete. Okay. So that's going to be 40. We can now factor out a 5, so we have 5 times x squared plus 1 equals 40. Divide by 5s. Okay, so now we have x squared plus 1 equals 8. Thanks. So then we have to minus the 1, so now we're x squared because the minus 1 equals 7. And now we got to take the square root and square root. So what we end up getting here is, you see, we're going to get x equals the square root of 7 as the final answer. So yes, I know that is definitely a lot of work on this problem. The SAT is going to kind of put you through the grinder on that one, but it is manageable. All right, everyone, let's check out and let's see at number 14 here. So one thing we should notice about number 14 in our first glance at it is that we have a exponential equation here. So we know that the formula here is going to be y equals a x to the b and stuff. And so that's the a. Remember, that's the percentage that's exponentially growing, and these are the number of terms and stuff. So, and it's asking us, and the equation above can be used to model the population in thousands of a certain city t years, and after 2000. According to the model, the population is predicted to grow 0.5% every n months. What is the value of n? So here we see that this t is making reference to years, right? And we're talking about months. And if we want to grow a full 0.5%, this is suggesting, this t over 3, the t over 3 is suggesting that we have to go up by a value of 1. Well, to go up by a value of 1, the t must be equivalent to 3, right? So 3 over 3 is going to be 1. So that means now we're going up a 0.5% here, which is being represented here. So if it takes 3 years for it to go up, population to go up 0.5%, okay, then the number of months, then 3 years is going to be equivalent to 36 months. So if you chose A as the answer choice, then you were correct mostly in your assessment. However, you factored in years and not months, and so the answer choice should have been D instead. Okay, number 15. So what we have here is that we're adding and subtracting of polynomials. And the thing to kind of keep in mind on this one is we have this expression here that we have to expand, and then minus this and stuff. So let's first rewrite this expression. So let's write 2x minus 2 times 2x minus 2. And then distribute, let's go ahead and distribute the negatives here that we have. So distribute them into both of them. So we can say plus, which would be actually, not plus. Let's get rid of that. Let's delete that piece. Okay, so in reality, that should be a minus 2x and then a plus 4. All right, so expanding this, so we're going to FOIL this out to the two pieces and everything. So now we get 4x squared, which will be minus 4x minus 4x plus 4 things, and then then again minus 2x plus 4. So let's combine all of our like terms. So 4x squared minus 4x minus 2x, which is going to be cumulative of a minus 10x plus 4 is going to be a positive 8. Okay, here what we can do is we can look and see what we can try to do here. We can pull out a 2. So 2, we're now going to make that 2x squared. Oh, I just realized I messed up, didn't I? Let me see. That's supposed to be, I'm sorry. So sorry. I don't know why I did that there. I'm sorry guys. Sometimes this stuff happens. So, my apologies. That's supposed to be a positive 2 there. So that's supposed to be a positive 2. It's supposed to be a positive 2. So let's try this again. So now we have 4x squared minus 10x plus 6. Okay? Well, and one thing we can try to do is we know in looking at this does not agree with A or B, right? Looking at these two. So looking at this here does not agree with A and B. So now we're just trying to find what's the factored one. Well, the easiest one is just finding the constant term. Negative 2 times negative 2 is going to be positive 4, which that does not necessarily work. That's going to be positive 4. So it can't be that. So negative 3 times 2 is going to be positive 6, which agrees with what I have here. So the answer choice is D. Okay. So just kind of make sure you keep your ducks in a row. You saw me kind of stumble through it just slightly. And make sure you're doing your diligence there. Okay, number 16 here. So here, this one is suggesting to us in the equation above, what is the value of S when t equals -1? So when you take this right here, plug it into there, I think so we can say 2s plus -1 equals 11. And then you got to move this over and add the 1. So now we are at 2s equals 12 and s equals 6. So that would be our final answer there on that one. You can see that one is pretty straightforward and simple. Here, again, what is one possible solution to the equation above? We see that we have an x squared variety that is being given to us. And so what that is going to suggest to us, remember when we see this equal sign in the quadratic, this is going to be, we're solving for our x-intercepts of things. And so we should know that. So let's expand this one here, x minus 1 squared. So that's going to be x minus 1 times x minus 1 equals 3x minus 5. So let's finish this side of the equation. So this is going to be x squared, be minus 2x plus 1 equals 3x minus 5. And we want to set everything to 0. So we want to move all these pieces over here. And so now we have minus 3x and then plus 5. So now we have, let's give us some more room here. So we now have x squared minus 5x, yes, plus 6 equals 0. And it's asking what is one possible solution. That means we could have multiple solutions. Well, our factors here have to be 6 minus 1. So that gives us, actually, I'm sorry, that is not correct. That does not work. So instead, it looks like our answer choices are going to have to be 2 and 3. So this has to be 3 and 2. And it would be both negative. So now we don't have x minus 3 times x minus 2 equals 0, or x equals 2 or 3 in this particular problem as our answer choice. Okay, number 18 reads, in the complex number system, what's the value of the compression 16 I to the fourth minus 8i squared plus 4, and what the value is of this expression. Thing to keep in mind, remember that I to the 1 is just equal to I, or the square root of negative 1. I squared is equal to negative 1. I cubed is equal to negative I. And then I to the fourth is equal to 1. So we need to understand we really need this one and this one in this equation. So writing this out, so 16 times I to the fourth, or 1, minus 8 times I squared, which is negative 1, plus 4. So 16 times 1 is going to give me 16. Negative 8 times negative 1 is going to be positive 8, plus 4. And so we can see the answer choice on this one is going to be 28. Okay. Alrighty. Okay, guys. Look at problem number 19. We see we have a function table here. All right. And we see that it is showing two pairs, and the function will be written in the form of f of x equals ax plus b. So remember, that is the same thing as y equals, okay, that's the same thing as y equals mx plus b, right? And so remember the slope here, remember our slope is the change of y over the change of x, which in this particular case, remember the same thing as y, is 5. That is 4. So that's going to be 5 over 4 is my slope. The other thing is, if we have the slope and if we have an ordered pair, we can always find our intercept. Remember that from the class. And so let's take this first one where we see x, y is equal to 8, 12. And so we also know the slope is equal to 5 fourths. So let's plug that in. So we know that 12, let's say y equals mx plus b. So taking these values, we see that y equals 12 equals 5 over 4 times what happens to be 8 plus b. So multiplying those values there, 5 over 4 is going to give me, what is that going to give me? We know that can reduce down to 2, right? So that reduces 8 over 4 reduces down to 2. So 5 times 2 is 10, so 12 equals 10 plus b. And then we can see that minus 10, so 2 equals b. So m, which is really a, equals b, the things. And so adding the fractions together, we have this kind of pretty nice little division here. We have a plus b. A equals 5 fourths, 5 over 4, plus b, which is essentially 5 over 4, so that's going to be 8 over 4, which is equivalent to 2. That's 13 over 4 is the answer choice. Okay, that is the correct answer choice there. All right, and the last problem here, let's look at number 20. It says the segments of OA and OB are radii of the semicircle above. Arc AB has a length of 3 pi, so let's say that's 3 pi. And the OA equals 5, so we know that is equivalent to 5. What is the value of x? Now remember that what we do know is that when we're talking about these ratio and proportions, that we know that the arc length, 3 pi, and then over circumference is going to be 2 pi r. So if we look at 2 pi r, the radius is 5, so that's going to be 2 pi times the radius, which is 5, which then gives us 10 pi, right? However, the circumference is for the full circle. We have a half circle there. So 2 pi r, which really we need to divide this by halves. So we now know the radius is now going to be, or the full length of this outside here. So if we're going from here to here, is only 5 pi. And again, this is a semicircle, so we then know this right here is 180 degrees. So that's why it's going to be x degrees over 180. So now we got a ratio proportion, remember part whole set up. We can eliminate the pi's here. So then we can cross multiply, so we have 5x equals 3 times 180. So 5x equals 540, and then x then equals 108, which is our answer choice for this one. So thank you so much. I hope you found this video to be very helpful in understanding the solutions to your problems on the test, and be looking out for the next section, which is going to be section 4. Thank you so much, and see you next time.